Hello, in this video we're going to take a look at one of the most important programming constructs, the idea of a variable. You may be familiar with variables from your math classes, but I think variables in programming play a similar but slightly different role. So first let's take a look at a problem where a variable would have helped us. So suppose we have our robot again, and the robot is facing a bunch of squares, and we want to write a method that determines, is the square in front of the robot dark? Is it dark in front? So I have my file here called lesson, and lesson comes with a bunch of useful methods like turn right and turn around and back up. And with that in mind, I want to write a method that determines if the square in front is dark. Now if I'm determining if I'm checking something, that tells me I want an answer that's going to be a yes or a no, or in computer speak, a true or a false value, a Boolean return value, public static Boolean, and this is going to test if the front is dark. How am I going to determine if the front is dark? Well, I can determine if I'm on dark. If I want to know if the square in front is dark, there's no choice but I'm going to have to move to that square in front. I'm going to have to test if the robot is now on dark. Notice whenever I write an if, I write the entire if out with all the parens and braces and else, and then we start filling in the details. So if we're on the dark, what do? Well, the answer is going to be true, I guess, and otherwise the answer would be false. And that sounds good at first, but I think it'll be obvious when we run it what's wrong with it. And we've seen this issue before, so see if you can guess what's going to happen when we load up our little hallway and we ask it, front is dark, and that method was in my lesson file. So is front is dark, is it? True. Is that good? Well, the true is good, but the fact that the robot ends up on that dark square is not good. So that tells me I should have backed up at the end. And luckily for me, I have a method called backup, so I could use that. So I'll just back up, oh, I don't know, how about after we test? Back up. How is that going to do? What's going to happen when I hit compile now? What do you think? Is compile off my screen? Yeah, it is, but I know F5 will compile. Error. Uh-oh. Can't do that. And it says unreachable statement. So it's telling me this backup statement is unreachable. And the reason it's unreachable is because in every possible scenario, I've either returned true or returned false. And remember, return doesn't just make a note of what the answer will be at the end of the method. It actually ends the method right there and then. So I've either already returned and left the method with the answer true, or I've returned and left the method with the answer false. So we never get to this backup line. So backup has to go before the returns. What about if we put it here? Oh, and I should remind us, just in case we're still new to this, when I call a method, I always write the file name dot the method name, and the move method is in the robot file, and the onDark method is in the robot file, but the backup method is in the lesson file. That's the file I'm in right now. And because I'm calling a method in the same file, it is optional for me to actually specify the file name, so I can omit that like so, and that will sometimes make my code a little bit easier to read if I don't specify the file name everywhere. I don't know, it's up to you. You can specify the file name everywhere if you choose, but I think you should know how to read code that doesn't have a file name. Alright, I just hit compile, and it's happy because I'm backing up before I return. But when I run the program, what's going to happen? In fact, let's take a look at what happens. So we'll load up my little hallway again, and we'll call front is dark. And the answer should be true, right? So we made it back, but we got back false. Why are we getting false? Ah, because we told the robot, take a step forward, then take a step back. In the middle, we didn't note whether the robot was on dark, so now we're only testing dark after we've returned. We backed up to the original square. Well, that doesn't make sense. The on dark has to be before the backup. So backup has to be after the test for on dark, but before the return. And if you think about it, there's only one place it can go then. It's got to go before each of the returns, knowing what we know about Java programming. And let's confirm that that works. So I compiled, I'm loading up my world, I'm showing it to you, and I'm testing front is dark again, and it goes forward, comes back, and returns true. That's a good thing. And I guess we should confirm that if it had been on a square where the front is not dark, and we call the method, we get back false. And we do. So, good method. Now, notice I have this call to backup appearing twice. And that may bother me, because I remember something from way back when, and that's this little rule, little guideline, that whenever I have duplicate code, I should think to myself, there must be a better way. There must be a better way. And there is. There is a better way. We can put the computer to work rather than have to write backup twice. And the way I can put the computer to work is I can tell the computer, you know what? At this moment, you knew whether the robot was on dark or not. Maybe we can restructure the code like this. I'm just going to write, this is garbage, this isn't real Java code I'm writing here. Test if the robot's on dark, then back up, and then return. Here, let's test robot on dark, and remember the answer. That's what I want to do. Test if the robot's on dark, remember the answer, then back up and return that answer we remembered. That seems like a better way to do this, right? Then I only have to write the backup code once. And although maybe this won't be a big win, maybe it doesn't bother you writing backup twice, introducing this notion of a variable to solve the problem is going to make this problem and many, many, many others much easier. It's going to dramatically change the power of the language and what we can do. So, duplicate code, there must be a better way. The better way would seem to involve remembering whether the robot's on dark. How do we remember something? So, whenever we want to remember something, we want our program to remember something, that's going to be the hint that tells us use a variable. What is a variable? A variable is a name for a place in the computer's memory where it is remembering a value. So that's a little different than math class. In math class, a variable is an unknown value that we're solving for. In computer programming, a variable is just the name for a place that we save an answer. So, where are we going to save our answer? Well, we just need a name. And I need to tell you one other thing about variables. I need to tell you what it looks like to store something in a variable. We use something called an assignment statement. An assignment statement. So here's a new kind of statement. So if you're keeping track, so far, let's make a note of our various statements. We have return statements, we have ifs, we have method calls, we have, actually I should write, they're usually void method calls, calling a method that doesn't return an answer, and while loops, right? I think those are the four kinds of statements we've seen so far in our programs. And now I'm introducing yet another kind. It's called an assignment statement, and it looks like this. We write the name of a variable. So I'm going to write it out like this. Name of a variable, an equal sign, and then some expression. So this is the variable name, and this side is an expression that evaluates to be some value that gets stored in that variable. And we use the equal sign, and what we think to ourselves is, let me write an example. Actually, we'll write an example in my program, and then we'll pick it apart, I think, in a moment. So here we go. Test robot on dark, and remember the answer. What we do is we say variable name equals some expression, and robot on dark is an expression. It evaluates to a true or false, and this says save that true or false in a place that I'm giving this name. Now, X is not a good name. A good name might be something that captures whether or not the front was dark. So let's call it dark, right? So dark is true if the robot was on dark when it moved ahead, and dark is false if we moved ahead and evaluated on dark and got false. Now finally, to return the answer we remember, all we need to do is say return the value of dark. So not only is dark a variable name where I can store a true or false value, but dark is also an expression that I can evaluate to get back that true or false value in order to return it. I think this would be a good place to stop, because at this moment we're probably feeling like, hey, that's kind of neat, we introduced a variable and it solved a problem for us, whoop-de-doo. But in the next video we're going to be bothered by the fact that when I actually hit compile in this program, so I'm hitting F5 right now, it turns out I have lied to you. There's something else we need to do. Java has never heard of this variable dark, so we'll fix that in the next video. I'll see you there.